Hello everyone, in this video I will show our new product, and you can see this is KinCony Z1. The Z1 means the Zigbee gateway, but this time we also integrate IR receiver, IR sender, and IF receiver and IF sender, just add the Zigbee module from Tuya. And this controller is a new updated version of AG smart controller. And it also can work with the Home Assistant by ESP Home, but this time we have designed this box made by ESP32 And also you can use the Home Assistant, it's very easy for IR and IF. And also you can use KCSV3 firmware because we have written the new Zigbee firmware to the ESP32 with KCSV3 so that this box can work with Zigbee 3.0 standard protocol product directly. So it can work without Home Assistant, work without ESP Home, work without Task Motor. So that can work with the Zigbee sensor directly. So you can make some automation with KinCony other controller, so that use a Zigbee sensor, maybe you have used a DOS sensor to control the KinCony relay controller, and your own relay board, all is no problem, because we have designed this for IFTTT function in local automation from the Zigbee sensor to automated control by the relay board or other KinCony board. So in this video, I will show you this hardware details and how it works with the Home Assistant and work with the KCSV3. Okay, let's look at this hardware firstly. Okay, you can see this is KinCony Z1, we call it Z1. And what is different? You can see this is a black plastic shoe, and you can see this is AG and this is Z1. But you can see in the interface, the USB part, this is older version, the USB mini part, and this time you can see we have used this USB-C, so that will be, you can use your mobile phone change gate cable, so you can see USB-C cable. And this time we have also modified the module. KinCony have modified the module. You can see this have a button. The button used for GPIO 0 for download for ESP32 and this power LED. And this is the Zigbee state, network state LED indicate. And this for pair with the Zigbee sensor. You can also use the KCS web page or use this button. And so this is what is different. So you can see if I connect with the USB-C cable, and this is power LED. Okay, now I will open this box and show you what inside of the PCB board. We can open the screw. Okay, you can see we can open this box. Open this box, and let's look at some details. And this one you can see that is ESP32. This time we have used by S3 new version, high speed and large memory size and PS RAM. And you can see this is IR turbo, IR send turbo. So you can see have a 7 IR turbo for different directions, so that you can set the IR signal to anywhere in the room. And this is the beep. This is beep when the Zigbee signal is learning successfully. That will have a sound, easy to understand. And this one you can see that is Tuya Zigbee module, a ZSU module from Tuya company. So we have read the Tuya firmware to this Zigbee module, and you can see this is IF receiver module, and this is antenna you have inside, and this is IF send module. This also the black is antenna. And this you can see there are many free GPIO you can use. This is free GPIO if you want one connect with sensor or connect with other device. So you can see there are many ESP32 GPIO, free GPIO you can use it here. So this we call KinCony Z1. Okay, let's close the cover and show you the function in software solution. Work with Home Assistant and work with KCSV3. And first, I will download the KCS firmware by the USB-C cable and connect this cable with my computer. And also I will show you how to integrate Zigbee sensor. You can see I have many Zigbee sensor. This is dot sensor, and this is temperature and humidity sensor, and also it's a light sensor, but we will integrate the temperature and humidity to the Zigbee gateway and to the home assistant will be very easily. Okay, and you can see, and this one you can see Zigbee PIR sensor, and this one you can see the SOS button, Zigbee SOS button. And also you can see this have a Zigbee switch panel. It's a Zigbee switch panel. You can see you can buy any Zigbee product, but must choose the Zigbee 3.0 standard protocol product. If you're not sure whether the product is suitable, you can buy this Zigbee sensor from KinCony company, because this sensor we all have tested is no problem and compatible with the KinCony Z1. So in this video, I will show you some typical Zigbee sensor. For example, I will show you how to integrate the dot sensor, this Zigbee dot sensor, and PIR sensor, and this temperature and humidity sensor. So this is commonly used. And in this video, I will show you how to integrate to the Z1 and in Home Assistant. And also you can see I have a KinCony smart controller. This is T32M, and actually you can use any KinCony controller or other company product. Just you have no understand the protocol for the TCP or from HTTP or from MQTT. So in this video, I will also show you how to use the dot sensor to trigger the T32M output by this Zigbee gateway without Home Assistant, without TUYA, and just locally run the signal to the Z1, and the Z1 send the signal by the network to the T32M controller. So that will be flexible. You can add many Zigbee sensors for the KinCony other relay board. Okay, let's begin. Okay, let's back to my computer. Now I will show you how to integrate to Home Assistant. And first you can see this is KinCony Z1. This is Z1 on our web page. Make sure this is very important. If you want to choose the Zigbee 3 product, you must choose the Zigbee 3 standard protocol product. So if you have some private protocol that can't used by the Z1. Okay, you can see what is inside, and some different solution, hardware solution, and the interface, and you can see the ESP32 IO pin define, and ESP home YAML file, and KCS v3, and how to use Zigbee about the KCS v3 online guide or at here. So you can see, you can click ESP32 IO pin define, and you will see what our pin define results. And this have a 7 IR turbo. This IR turbo and controlled by 2 GPIO, GPIO 47 and GPIO 48. You can see because the 47, the IR turbo used by D1, D2, D3. This is D1, and this is D2, and this is D3. So this 3 IR turbo used by GPIO 47. And this one you can see that have a 48 used by D4, D5, D7, D8. So you can see D4, this one is D4, D5, D7, and D8. So this one used by 48 GPIO. So this is two different. I just want to tell you. So this means that text TX1 and TX2. So that will be used in KCS web page. Okay, this is free GPIO you can use, and also you can see we can use by KinCony KCS firmware. That is very powerful because we spend many months to develop the Zigbee firmware and the KCS firmware. So this time all have successfully, and we have released this product and the new firmware. So you can see you can download the KCS v3 firmware from our form. So you can see, you can download the firmware at form, just by this form. And you will see the KCS at here. You will see the KCS v3. And you can see this v3, the new version, downloaded here, so that you can see the Z1. So now I have already downloaded it. Now I will use the ESP downloader tool, download to the Z1. So you can see I can choose this ESP32 S3 and choose USB and OK. And this time you can see I just choose this one, select this one and select the file you have downloaded, and the address is this one, and choose the component and press erase. We can erase it firstly, so we'll erase all chip of ESP32 S3 and then press the start button, and the firmware will be downloaded again. Okay, after download, you can close this window and close this window, and must repower on the USB-C cable. So you can just disconnect and connect the USB-C again. So you can see this is power LED. And now we will back to my computer. And you can see after the Z1 began running, you can see the Wi-Fi hotspot. You will see this is Z1, a Wi-Fi hotspot. The first time we need to connect with the Wi-Fi AP mode directly and set the Wi-Fi to STA mode so that can let Z1 connect to your loader directly. So I can click connect. Okay, that have connect. So that I can use this IP address to visit the Z1. This is Z1, default username, admin, password, admin. So login, so you can see this is Z1, and the first I need to set the network. I want set to STA mode, so that this is my load SSID and my load password, and press save and press OK. So that lets the Z1 connect to load directly. And after reboot, you can see the web page will not work because the IP address is changed. So I can use this KinCony scan device. Where to get the KinCony scan device? You can also see our online guide, KCS v3 online guide. You can see that have a download link. You can see you can download it here, UDP scan device tool at here. So you can see I can choose my computer. My computer is connected with the Ethernet cable, so I choose this Ethernet network card and choose this computer's Ethernet IP address. Click Start Monitor and click Scan. And now you can see these two controllers have been scanned. One is T32M. I want to use Z1 to control the T32M by the Zigbee sensor. And this one you can see that is Z1 3.1. 02. So I can use this new IP address 3.102. Enter, and you can see this time I can enter the Z1 again. Okay, you can see this IP address of the Wi-Fi, and you can see the first index web page that showed all the information, all the firmware, all the data for the Z1. And this one you can see I can learning the RF signal and learning the IR signal that you can use in Home Assistant. For example, I can at here. We can look at the monitor the web page firstly. You can see the sensor is empty, IF output empty, all is empty. But I back to the IF web page. And you can see this is 433 MHz remote. And this is a TV IR remote. So the first time you can see, I can click this learn. So I press this button. You can see successfully So this IF signal have been learned, and this time we can back to monitor, and you can see the IF input have an IF signal. So I can press this button. You can see it's turn green, and also you can press this button. That means it will send the learned IF signal that can be learning your maybe your fan or maybe your curtain as a remote. You can learn it and send it in Home Assistant or in KCS web page. Okay, you can see the IF I have learned and I can send it. And also you can see I can click the IR. The IR you can see I can set a TX channel, because if I learn a signal I want to send out. So this time we'll have a TX1 or TX2. Just I have told you how to choose this one, and you can see the IO pin define. That means the TX1 and the TX2 just different GPIO for different IR turbo. So this time, for example, you can choose this one, TX1 channel 1, have some IR turbo. You can see I can click learn. I can use this one. Press the button. Okay, you can see successfully. And you can see this have learned my TV is a NEC IR code. And also I can learn this for another channel, for another turbo. So you can see I can press this learn button again and use this IR remote, press this button. So you can see that have learned the second. The second you can see different command, second button. And also it have a function. If you want copy a code, because maybe you want to send to another signal from the learned signal, but you don't want to repeat to learning. So you can see this have a copy function. For example, I want to create the number 3 IR ID as same as the first one. So you can see I can click copy and copy from, I want copy from the first one. You can press 1 and press copy button. So you can see the 3 IR ID as same as the first one. And you can choose this one or this 2. So this is for the IR, learning IR signal. And we back to the monitor, and you can see, this time you can see I have learned the 3 IR signal showed at here. So I can press this button. So you can see, press this button and it will be turn green. Press this button and you can see turn green. So this time you can see this can use a sensor, the IR remote use a sensor in Home Assistant and in KCF web page, and also use in IFTTT for local automation. Okay, and you can see I can learn the IF and I can learn the IR and send the learned IF and learned IR signal. Okay, and let's to the next step. You can see the sensor. If you want, connect with a different sensor, because we have some free GPIO on the PCB. So if you can connect with the PCB soldered by yourself, so you can extend some different sensor at here. And this is the monitor. And this IFTTT, later I will show you how to make automation. And the next you can see, we can look at this protocol. This is important, and you can see this have a different protocol, KinCony Cloud. You can remote control your IR device or IF device. And this is the Home Assistant. For Home Assistant Auto Discovery, I will show you integrate to the Home Assistant. We have learned the IF and IR device. And let's look at the Zigbee first. You can see the Zigbee. And the first, I want to learn this door sensor. So I will show you. And the first, you can click this one. Enable the Zigbee option. And this also you can see option just when the Zigbee sensor is learned successfully, will have a beep. So if you want to enable it, you can enable it. If you don't want speed up sound, you just disable it. I can enable it, so I will show you easily. And press save. and refresh. Okay, this you can see Zigbee learning device permit join. So you can see if I press this button, this will wait about 120 seconds for my to prepare this signal. Now I will shut for this trigger the signal preparing. So you can see, you can see, hold on. Okay, this LED will blink. Okay, you can see it beep twice because we have enabled this one beep. So you can see this dot sensor have been learned at here. That means it's online. Okay, and now we can back to my monitor web page, and you will find this have a digital input. It's digital input 1, but also you can rename by yourself. You can see you can rename input 1 or input 2 or dot sensor or window sensor. You can rename by yourself. So you can see the dot sensor. This is closed. See my compute, and you can see this green, off, on, off, on. Okay, so you can see this Zigbee sensor, dot sensor is paired to the Z1. It's very easy. Now we will continue to learning the temperature and humidity sensor. We can enable this one. Just hold on this button and to pair with the signal. And you can see this one that have learned is online. And we back to the monitor, and you will see this have a temperature and humidity. Just this data have sent to the Zigbee gateway, and you can see the value. This is the value have updated to the Z1. And the next, let's compare with the PIR sensor. PIR sensor pair, and this one, this have a button. I can press this button, that will be blink. Okay, now you can see the third sensor have added to the Z1, and I back to the monitor. And this time you will see this one. This one is second digital input 2, because I have in front of this sensor, so it have triggered, so it turn green. I can put it beside of my compute. Okay, so you can see the first one just a dot sensor, and the second one is a temperature humidity sensor, and the third one is a PIR sensor. Now I have learned 3 Zigbee sensor and some IF signal and some IR signal. Now I want this update to Home Assistant, so we can use the Home Assistant auto discovery function for MQTT. Just you can see it here, and enable this one, and the device we call Z1. For example, you can see this is my Home Assistant dashboard. I can click these settings and click this device, and you will see this is all KinCony controller have used the MQTT connect with the Home Assistant, and this is no Z1. So this I just set the MQTT broker IP address. So I will check my Raspberry Pi Server 16 controller IP address. In my load, you can see this is the LAN. So my Home Assistant is this IP address. So I install the MQTT mosquito at here. So I use this IP address, and this is the port, and this is username and the password. This information according to yourself. This is my mosquito MQTT broker information. And I can press this save and press this OK. And wait for a moment when it will be reboot. Then we can back to our Home Assistant dashboard. And you can see this Z1 have auto discovered. We can click this Z1, and you will see this is digital input 1, digital input 2. This is Zigbee sensor, and you can see this is IR IR signal, and this is RF signal, and this is temperature and humidity, also is Zigbee sensor. So you can see, this is dot sensor. I toggle, not toggle, on, off, on, off. So this can work in Home Assistant. And also you can see, this is the IF remote, maybe have an IF sensor. You can see I press this button. You can see the IF is changed the state. And also I can use my IR remote. You can see I press this button. You can see this is changed the state. Okay. And this one you can see my temperature and humidity sensor. Also we update the date to Home Assistant. So this Zigbee sensor, IR device, IF device, all results have updated to Home Assistant. And also you can make automation by Home Assistant. It's no problem. Okay, this is very easy. Just only 1 minute to set up in the Home Assistant auto discovery function. You can use all sensors working in Home Assistant. And next, I will show you how to make an IFTTT command to constrain KinCony or other relay board by the customized protocol. And it's also very easy. Just you should know the relay board protocol, because I have used a T32M that support. You can see at here that this is T32M that support MQTT, HTTP, TCP, and UDP. So this time I show you how to use the TCP server and the TCP client to send automation by the customized protocol. And you can see the first step you need to understand how to control relay 1 on and control relay 1 off this command. Let's look at the KCSV3, the stream protocol. So that will be send out 2 command. It's also very easy. You can see at here KCSV3, and that here was string command. Very easy to understand string command. And also you can use HTTP command. So this is a protocol document. Click, and we can see how to control on and off. You can see set 1 channel digital output on and off. This called relay 1 off. You can see digital output 1 off. And if you change to 1, that means on. So we can test with this command. So you can see relay set this relay 1 on. And this command relay 1 off. So I will test with it, because the first time you need to set the T32M relay board work at the TCP server mode, and the local port 4196 is up to you. You can change any port. And I will use a network debug tool. You can see this is a debug tool. This is a client, because the relay board is a server, so I'm using a client software. And this is IP address is the relay board IP address, and the port as same as this part, just as same as this part. So I can click connect. So I can copy this one to turn on relay 1, turn on output 1. You can see this is my T32M, this LED is off. So you can see I can send this command. So you can see this is on. And also this is command for off. This is for off, just the one change to 0. I copy and paste it here. You can see I send the command. So you can see the relay is off. So I want a Zigbee.sensor to make an automation for relay on and off by this dot sensor. So this will be very easy. Just use this 2 command, make a customized command, and you can see I disconnect it and close this door, and back to my Z1. And I will create a customized protocol, and the first protocol that will be turn on relay 1. So you can see the option I use TCP client and turn on relay 1. Just this command, copy it here, and don't click this one. Just we have use NC stream. And the second you can see also used by this command, and turn off relay 1. Okay, now you can press save and press OK. And we will back to the protocol. And we need to enable the TCP client, because when IFTTT will use the TCP client, just work as same as my PC software. This is a debug tool. So you can see I want connect with the remote IP remote address is a relay board. This one is this address. So you can see this is relay board address, and the remote is this one, as same as relay board. So you can see I can press this save. Press save. Okay, let's refresh and back to IFTTT command and edit the IFTTT1 that called relay 1 on. Enable this IFTTT command, and the DI, the first DI is a DOS sensor. I have learned the DOS sensor, so I can select the first DI is true. First DI is true, just the door is opened. So press this button and let the custom size protocol, the custom size protocol 1 is relay on. So I choose this one and apply and press save and press OK. So if you can see my DOS sensor, if I open on, you can see my 32M, that is on, okay? But this time I want close it, it will be off. So I need to create the second IFTTT command. So this time you can see I only on off, that will be on. So this time I need to add the second IFTTT command. So I can press edit, and this time is relay 1 off. Enable this one and press select DI1, and this is false. If the false, I want to send a custom size protocol number 2, that is turn off relay 1. So I can press save, OK, and return. You can see the second IFTTT is created. So this time you can see the DOS sensor open, on, close, off, open, on, close, off. So this help make automation from the IFTTT by the Zigbee sensor and the Z1. That will be very easy. You can see, very easy. Okay. So this is the DOS sensor. I have created IFTTT command, and also you can create such as you can use a temperature sensor, so that you can use the sensor and the temperature and the humidity, compare a value to send a custom size protocol. Also, is no problem. Let relay on off according to the temperature sensor. No problem. So this is a powerful function for the IFTTT and for the local IFTTT with the Zigbee sensor without Home Assistant. But also you can create, modify the Home Assistant config file for automation at here. But I think used by KCS V3 will use the local ESP32. If Home Assistant is broken or if the server is broken, also the automation will running well. Okay, thanks for watching.